Okay, in this section we're talking about absolute maxes and mins, and we're talking about critical numbers. When we get ready to find the absolute max and min, what you must know is that that occurs at a point called the critical number. And the way that you find the critical number is you take the derivative and you set it equal to 0, or you see where it does not exist. So in this first problem, I ask you to find the critical number of this function. To find the critical number, we first must take the derivative. Once we take the derivative, we see where the derivative equals 0 or where the derivative does not exist. Okay, in this particular context, with this blue derivative that you see, does not exist is not an option. The derivative does not exist if it has a denominator. Since this one doesn't have a denominator, we don't have to worry about where it does not exist. We do have to worry about where it equals 0. So we're going to take 3x squared plus 12x minus 15 and set that equal to 0. When we're factoring this, we notice that they all have a factor of 3. So let's take that out. Once I factor out the greatest common factor, it becomes an easy trinomial after that. The factors of 5 that subtract to give me 4 are 5 and 1. We can set each of those factors equal to 0. Well, we don't have to worry about the 3. We can divide both sides by 3 and that part would go away. So we're going to set x plus 5 equal to 0 and we're going to set x minus 1 equal to 0. So solving that out, we would get that x equals negative 5 and we would get that x equals 1. And those are the critical numbers of this function. Now that we've learned how to find critical numbers, we can worry about finding extrema. So those are the highest or lowest points. So the first thing you're going to do is find the domain, find all critical numbers, calculate the value. Notice that that's f of c, which is the original function. Calculate the endpoint values, and the max and min are given the largest and smallest. The max and min are the largest and smallest values once you calculate those. First, I give you a little graph. I ask you for the absolute and local max and min values of this function. Well, if you look at this particular graph, obviously this point here is the highest. So we would have an absolute max at 3. Now I said at 3, that's where x equals 3. So sometimes it'll say at a point or it'll say an x value. So you could either say you have an absolute max at x equals 3, or you could call that the point, it looks like 3, 5. It's not the best graph, I do apologize. You also have an absolute min right here. That's the lowest point when compared to points nearby. So you have an absolute min when x is 6. Sorry, let's see if we can get that better. There we go. You have an absolute min when x is 6. If you wrote it as a point, that would be the point 6, 2. So that's how we start that particular part. Now the last one in this section that I ask you to do would be to find the absolute max and min of this function over the given interval. The first thing you have to do with this function is find the domain. So the domain of this polynomial function would be all real numbers, so that's a good thing. The next thing that we have to do is take the derivative. The derivative of this function would be 12x squared plus 10x minus 42. That would be the derivative. So what you do next is you take that derivative and you set it equal to 0 to see where the derivative equals 0. That gives you your critical number. What I notice about this is that they share a common factor of 2. We can factor this polynomial. You can do it by trial and error. You can do it by bottoms up. It doesn't matter. You just have to be able to factor it. I'm going to choose the factors 3 and 2 for 6, and I'm going to try the factors 7 and 3 for 21. This gives me 9x, and this gives me 14. So I need the 14 to be positive and the 9 negative. To solve out this equation, I'll divide both sides by 2, so the 2 goes away. So then you just have 3x plus 7 equals 0, and 2x minus 3 equals 0. Solving that out, we would get that x equals a negative 7/3 and x equals 3/2. Those are our critical numbers. So reading through the steps again, the first thing that we needed to do was find the domain, and the domain of this particular function was all real numbers. So our second step was to calculate the critical numbers. These blue numbers are our critical numbers. The third step is to actually find the function value. Now my interval is -1 to 5. What I notice about negative 7/3, if you wrote that as a decimal, that's a little bit less than -2. So this one is not in the interval. Since this is not in the specified interval, we don't have to use it. We do have to use the 3/2. So what we have to do next is find f of 3/2 because that's our critical number that's in that interval. We also have to look at the endpoints, f of -1, and we have to find the endpoint f of 5 as well. Now when we're plugging these values in, you'll notice that we are plugging them into the original function. Once we get these values, we plug into the original function. So if you take 3/2 and plug it in, you would have 4 times 3/2 cubed plus 5 times 3/2 squared minus 42 times 3/2 plus 7. Now if you plug all of that in, what you get for that value is negative 31.25. The next thing that you would plug in is -1. So that would be 4 times -1 cubed plus 5 times -1 squared minus 42 times -1 plus 7. And if you plugged all of that in, you would get 50. Lastly, you plug in 5. Remember, we're plugging into the original. 4 times 5 cubed plus 5 times 5 squared minus 42 times 5 plus 7. When we plug all of that in, we get the value 422. The directions for this problem asked you for the absolute max and min. The absolute max occurs at the highest point. So the highest point would be the y value 422. So the absolute max would be 422. Your absolute min occurs at the lowest point, the lowest y value, which is negative 31.25. So this would be the point, x being 3/2, negative 31.25. And that's how you would do that part.